Okay, so for our next section, we are going to be looking at applications of systems of equations. So again, we're still looking at systems, so we're still looking at two distinct equations. So I want to remind you that every single one of these problems that we do today are going to have two different equations with two different variables. Now, when I do problems in this section, I like to use variables that represent the names or things that I'm looking at. So unless it says otherwise in the problem. So our first type of problem, we do have three different ones we're going to work, or three different types of problems we're going to work today, is what I like to call an age problem. So we have Frank is 25 years older than his sister Gloria. In 6 years, he will be twice as old as Gloria. How old is each of them now? Okay, so for our first sentence, it is really a strict translation sentence. If you remember what things mean, it's going to make it a whole lot easier. I'm going to use the letter F for Frank, since that's his name. It makes it easier when I go back and look instead of using X and Y. If you'll remember, is equal to, and then we've got 25, and he's older than. Older than is an addition, so think about if you have a brother or sister and you're 5 years older than them, you add 5 years to their age and you get your years. So older than is always going to be plus. And then his sister Gloria. So our first equation is going to be F is equal to 25 plus G. Okay, now our second equation is a little bit harder, but it's not horrible. But what we have to acknowledge is this in 6 years. So if you think about yourself right now, and if you're 20 years old, and in 6 years you're going to be 26, so you add 20 or you add 6 to your current age. So in 6 years, if Frank is F, he is going to be F plus 6. That's his new age in 6 years. Same thing with Gloria. In 6 years, Gloria is going to be G plus 6. So then we can look at our statement and say, okay, well so that's Frank, F plus 6, that's his age in 6 years. Will be is kind of like is, so that's our equal sign. And twice as old, that's specific, that means times 2. So we're going to take and multiply Gloria's age, which is G plus 6. Remember, in 6 years, she's going to be 6 years older, times 2. So we're going to need to use parentheses and do 2 times G plus 6. And there are our two equations. So make sure when you're doing this that you acknowledge that in 6 years, or it could be in 15 years, whatever it is, and you're going to add that to their age from the very first sentence. So our sentences are going to look like this. Now, we can solve this any method we want. We can solve it with substitution. We can solve it with addition. I guess you could even solve it with graphing if you just felt the need. However, this particular problem, if you'll notice, is already set up for substitution because you know that Frank is equal to 25 plus G. So all we could have to do is take this statement, 25 plus G, and substitute it in for Frank in our second statement. So we would have 25 plus G plus 6 is equal to 2 times G plus 6. And we're just solving for Gloria, or G. One of the things I want to do first is definitely add this 25 and 6 together. They're both on the left-hand side, so we can do that. And that's going to give us 31 plus G. And the other thing is on the right-hand side, we want to distribute that 2. That's going to give us 2G plus 12. I like to move my G's together first, so let's subtract G from both sides. So now we have 31 equals G plus 12. And then our last step to find Gloria here is that we're going to subtract 12 from both sides of this equation and do 31 minus 12. And 31 minus 12 19. So right now, Gloria is 19 years old. But remember, we don't just want to find Gloria, we actually want to find Frank as well. So we know that Frank is 25 years older than Gloria, so all we have to do is say, okay, well, Frank is 25 plus Gloria. So Frank is 25 plus 19. So Frank is 44 years old. So now we know Gloria is 19, Frank is 44. Okay, so for our next problem, our next couple of problems, they're going to be what we call number problems. And these truly are just a strict translation from the English of the word problem into mathematical phrases. I do want to point out, however, that you do have two distinct steps in this particular problem. Step one is they actually want us to write out the two equations, and then step two is to actually solve them. And this is the easier of the two, or the two number problems that you'll see in your homework. Notice that in here it wants us to use the variables x and y. What you might do out to the side of your problem is say that x is your larger variable and y is your smaller. This just makes it easier, especially on the bigger translation problems later on in the next example. So if we look at the problem here, it says the sum of two numbers is 47. If you'll again remember that sum means addition. The two numbers we're looking at, that's our x and the y. Remember, is again is an equal to. So this is going to be x plus y equals 47. Now, the second one says there, which is referring to the x and y. And we have the word difference, which means to subtract. Again, we're using that word is, which is an equal sign, is 11. So our second sentence is going to be x minus y equals 11. Notice in the second sentence that I do put my smaller variable second. It's really, really important that you understand that when you do this, your smaller value is the back of your subtraction, so x minus y. That's our step one answer. That's what we would put into Hawks for step one. Now step two is asking us to solve this. Well, I don't know about you guys, but I like to make these things as easy as possible. If you'll notice, your y's here are already opposite of each other. One's a positive y, one's a negative y. So this guy is completely set up to do our addition method that we learned in the previous section. So that would be the method that I would choose. However, if you like substitution and that's the one you want to use, definitely go for it. Solve for one of those variables and substitute it in. It'll work just as well. I'm going to go ahead and take these two equations and add them together using our addition method. X plus x, remember there's a 1 in front of each one of these, so that's going to give us 2x. Our y's are going to cancel out. And 47 plus 11 is going to give us 58. We're going to then divide both of these guys by 2. So 58 divided by 2 is going to give us 29. So our larger number is the number 29. And again, what we want to do is take one of these two equations, substitute our 29 in for it, and see what our y value, our smaller value is. So I'm going to just go for the first one here and say 29 plus y is equal to 47. So we're going to subtract 29 from both sides. And y is equal to 18. Now the biggest thing you have to remember when you're doing your homework for this particular section is to pay attention, because you do need to put these in their labeled boxes. So there'll be a box labeled large, there'll be a box labeled small, so put 29 in my large box, 18 in my small box. Okay, so again, we're looking at a number problem. We still want to do our step one and step two, where we are first setting up our two equations, again using the variables x and y, and then our second step is to solve these two guys. This is similar to the last one, but just a little bit more different. Again, out here to the side, I want to say that x is going to be my larger number, and y is going to be my smaller. And it's real important just to kind of set that up to begin with, so that you know when you're looking back at the problem that those are your values. So the difference between the two numbers, again, difference means subtraction. The two numbers we're looking at, that's our x and our y, is 103. So our first equation is going to be x minus y equals 103. Okay, so now our second one, it says 7 times the smaller. Okay, so 7 times, and remember we labeled our smaller value as our y, so that's going to be y, is equal to 5 more than means plus the larger. Well, remember we labeled our larger as the x, so that's our second equation. So we have 7y equals 5 plus x. And there's our two equations we're going to use to solve this problem. Again, at this point you need to decide which method you want to use to solve this. We can either do the addition method or we can do the substitution. It does not matter which method you choose, you will get the same answer either way. I'm going to go ahead and do this with the addition method again. One of the things that we need to do though before we start the addition method is notice that my x is over here on the right hand side and I need him to be over here on the left hand side. So the first thing I want to do is I want to subtract this x so that I'll have everything, all my variables on the left hand side for my addition method. So I'm not changing this first guy, he's going to stay x minus y equals 103, but this guy is going to now be negative x plus 7y equals 5. Now, again, notice my x's. They're already opposite of each other, so I don't need to do any of the fancy LCM stuff because my x's will already cancel out. It's one of the reasons I like the addition method, especially for these problems like this, because usually you'll see that you've got one that's canceling. So we're going to cancel those x's out when we add our equations together, and 7y minus 1y would give us 6y equals 108. So now we're going to divide both sides by 6, and y is equal to 18. So there's our y values. Remember, our y value is our smaller value, and now we need to go back and find our x. Again, we can plug it into anything we want. I'm actually going to plug it into this first one. That looks like it's going to be the easiest one to do. So we're going to say x minus 18 equals 103. So to solve for x, we're going to add 18 to both sides. And 18 plus 103 is going to give us x equal to 121. So now we have our larger value at 121 and our smaller value at 18, and those are our answers.